Hello, welcome back to another video. Let's take a look at this momentum and impulse question. A simple rocket system consists of two parts, a mass of 3m and B of mass of 2m as shown in the diagram. B is stacked on top of A. 17.1 state the principle of conservation of momentum. You have that, so we won't go through it. The rocket is traveling vertically upward at a constant speed v when an internal explosion causes A to move downwards at a speed of 1 over 3v. Ignore all external forces on the rocket. The question reads, calculate the velocity of B in terms of v immediately after the internal explosion. So since this is an explosion type problem, we're going to use the formula of principle of conservation of momentum. We're going to use a different variation of it. And the variation we're going to use is the variation for explosions. For explosions, we say that m1 plus m2 multiplied by v equals m1 v1 plus m2 v2. So the momentum is combined, the masses are combined rather, before the explosion, and after the explosion they move independently. They are separate, in this case it's two separate pieces. Now let's substitute. Before we substitute rather, let's choose a direction as positive. So we're going to choose up as positive. Now m1 plus m2 is 3m plus 2m. And it's moving at a velocity of v, and that's equal to 3m multiplied by minus 1 over 3v. Now I'm saying minus 1 over 3 because that's going down and we chose up as positive. And then plus 2m multiplied by v2. So the velocity after, the final velocity. Now remember, v2 is what we want. So we need to simplify and then take everything over. So 2m plus 3m is 5m v, and that's equal to 3m multiplied by minus 1 over 3v is minus mv, and then plus 2m v2. Keep in mind again, v2 is what we want. So we can take minus mv over. That's going to give me 6mv equals 2mv2. We can then divide both sides by 2m, divide by 2m, giving me, so that's going to divide, that's going to divide. So 3v is equal to v2. Since it's a positive value, it means it's 3v upward. Okay, next question reads, the graph shows the average force exerted by A on B during the internal explosion as a function of time. Name the physical quantity represented by the area under the graph. So area is length times breadth. In this case, length is time and breadth is f. Now let's rearrange that. So f times delta t, and we know that f times delta t is impulse. So the physical quantity represented by the area is the impulse. Next question, 17.4, redraw the graph in your answer book on the same set of axes. So let me just clear some space. Right there and there. So here's my original graph. Okay, time and force. On the same set of axes, sketch the graph of the average force that B exerts on A as a function of time. So always remember that This type of question is usually testing to see if you recognize that this is a Newton's third law problem. The force that A exerts on B is going to be equal to the force that B exerts on A, but in the opposite direction. So how do we represent that on a graph? The opposite direction will just be this. I'm just shading it in so we can see it. This is the force of A on B, and this is the force of B on A. Okay, and that's it. If you liked the video, please leave a like, share, subscribe. If there's something specific you'd like to ask or you want to find out, you can let me know in the comment section below. And until the next video, bye-bye.